Glad. There we go.
Very good. Okay, well, welcome to the August 2nd, 2022 session of TangerineSDR and Hamside technical session. My name is Dave, KV0S, and this week I was working on an antenna again and straightening out some issues I had with my computers. So both of those and helping my wife. She's had some illness. So basically, that's about it for me. Next on the list is Nathaniel, W2NAF. Go ahead, Nathaniel.
Thanks, Dave. Things are going well here. Last week we had our Radio Blaster physics camp. So we had about 10 high school students come up to the university and we had them do all sorts of things, starting with like actual, some wave experiments with optics, and then they went into circuits. And as you saw from the listserv, we actually set up the ham radio outside and tried to have them make some QSOs, and they did things with Kiwi SDRs and listening. It was a lot of fun. So I think that worked out really well. Bye, Anthony. And the research students helped out with that. Then along with that, we're trying to get ready for all these, just keep up with all the different research activities. So we're getting ready for the American Geophysical Union meeting, which is in December, but the abstracts are due on Wednesday. So I think what I'm doing, let's see. I'm doing one abstract on super darn traveling atmospheric disturbances, so not really related to this project. I'm thinking about also putting in an abstract that kind of covers the whole Personal Space Weather Station project as a whole. So that would include a little bit of, the tangerine status, the grape status, the magnetometer status. I do like one overall topic. So I need to put together an abstract for that. So I'll probably get that together tonight or tomorrow and then email a bunch of people and say, would you please be a co-author on this? And we'll get that going. Christina and Veronica are each going to be doing different talks on the or different presentations on grape results. I asked Bill Engelke to put together an abstract on the central control system. So he sent me a draft of that today. So I have to get that back to him. So I think that's pretty much what I have going for AGU this year. So that's probably enough for now. So back to Net.
Fine business. Next on the list is Dan in for XWE. Go ahead, Dan.
Thank you, Dave. Can you hear me okay?
Yes.
Okay, perfect. It's kind of busy this week doing a little bit of Raspberry Pi figuring out, trying to work with Bill to overcome a couple of issues he's been having with his Pi, and I think we got some of it sorted out. Anyway, that's about it from here. Just trying to stay cool and stay dry. Talk to you later.
Yes.
Oh,
Please.
I forgot one person. Steve Serwin also submitted an abstract about his Doppler observations.
Oh, okay. Very good. Next on the list is Dave, KD0 EAG. Go ahead, Dave.
Oh, I've been, what did I do? I finally got a refresh, a new version of the RunMag program up on GitHub, on my GitHub, that needs to be shaken a little bit to make sure it's doing what it's supposed to. But basically the primary intent was to make sure that it's getting the full number of once per second samples in a day's time, 8,600 or whatever it is that it's supposed to be in there. And which it was falling just a little short of. Also I put up, there's also in the logs file folder a JSON file, metadata.json file that's kind of in the format that we were going to use for now. about to describe each workstation or each node. I'm sorry. And just for the time being. Also, I have been experimenting with using PMMI or PMMA plastic fiber optic, low-cost fiber optic stuff, kind of like Toslink for audio. But it's used sometimes for industrial communication amongst things, and it looks like they're going to use it a lot in cars maybe in the future. So I have half a kilometer of this stuff that I've never gotten around to testing, seeing what it would do. But I sent some off to Amartya, a high school student who's been working with me just this afternoon, and I did some superficial experiments and loopbacks and stuff, and it's really easy to work with. It's extremely tolerant. You can cut it with scissors and stuff like that. So it's nice, whether it's rugged for, you know, outdoor use. Well, you can get it with that's connectorized better than this is, but I just want to see if that's a viable alternative. By most accounts, it looks like it would go a kilometer or so. At least. So just finally getting around to playing with that, and destroyed a laptop in the process just by plugging a USB-C, not plugging it in, just sticking it in USB-C connector into a USB-A port, and thing just fell like a sack of rocks, but hadn't come back. So I may be buying a new laptop. That's it for me.
Well, sorry for that, but I mean, things happen, I guess. Next on the
I'd
list.
never get a new one if I didn't I didn't kill one now and then. That's the best thing.
Next on the list is David in one HAC. Go ahead, David.
Hello, everyone. This past week was primarily working in the terahertz range, as I said. It was the Springfield Telescope Makers annual Stellafane conference. We become the largest campground in Vermont the week that we put on our conference. Went very well. We had a deluge. Our requisite deluge on Thursday, which was a good time to have it. And then the rest of it was fairly good weather. But I also did have ham radio functions because we have the W1 STM Springfield Telescope Makers Amateur Radio Club. And I was going around getting people to sign in who were there. We have a lot of crossover, of course, between telescopes and astronomy and amateur radio. In fact, we used to use amateur radio for communications before the family radios came out. And I was talking up HamSci a bit, and we were talking about next year, which is our 100th anniversary of the club, which will be, we'll presumably put on a special event station. So that's the extent of my activity for this past week. Now we'll get down to the low bands. Thanks.
Very good. Sounds like a good set of events. Next on the list is James, KG4 DSG. Go ahead, James.
Yeah, you caught me snoozing over here. Just listening tonight. Not much going on here. Keeping an eye on the weather. We got some storms coming in. And with that, back to the net.
Okay. Next on the list is Jim, K4 BSE. Go ahead, Jim.
Oh, good evening. Still not a lot going on here. Got a lot of antenna work I need to do. It's just too dang hot to do it. So just been sitting inside and trying to stay cool. Hopefully I'll have something better to report later. Back to net.
Well, fine business. And next on the list, we have Joe, W7 LUX. Go ahead, Joe.
Thank you, Dave, and good evening, everyone. GRAPE is collecting data daily, and I've been working on high frequency antennas. We've got a couple of public service events that stretch out over 60, 80, maybe even 100 miles. And VHF just doesn't, or UHF just doesn't cut it. There's only one repeater, one unreliable repeater that covers that area, even partially. And so I've been working on portable high frequency antennas so we can keep in touch. And one of these events is a 100-mile run that's a 30-hour event, and we've had a number of people get lost. So our coordination communications is kind of important. Well, it's overnight, and I guess we're sitting out there, 1, 2, 3, 4, counting steps at night. Pretty easy to miss a marker, and we have seen some big cats out there. So we try to track everybody really, really carefully. Anyway, we're working on antennas and trying to avoid the thunderstorms in this area. Back to you, Dave.
Fine business. Next on the list, we have Jonathan, KC3 EEY. Go ahead, Jonathan.
Hi, everybody. It's been a pretty busy week for me. I've been working on some minor modifications to the mechanical build of my H-Field VLF receiver. Some additions, including connections for a calibration port that allows you to inject a calibration current into your loops. I'm also looking at mounting everything and laying everything out. It's going to be built Manhattan construction. That's how I like to build my VLF receivers. So I'm in the process of that. The interface board for the H-Field receiver is that interfaces the H-Field receiver with the Raspberry Pi. It sends out power and also uses audio isolation transformers. And I finished wiring up that board completely. I built it on a perf board, and the way that I built it was you have the choice of using either 24 volt or 48 volt DC to DC converters. So 48 volt DC to DC converters would be used for extra long lengths of cable. So the voltage drop at the other end would be within the 24 volts, or the 30 volts. And I used pin sockets, gold plated, obviously, that you just plug in the appropriate DC to DC converters with the one for the H-Field receiver and one for the E-Field receiver. Remember, this is a 3-channel system. So you have 2 H-Field and 1 E-Field channel. So that's coming along very nicely. I've been thinking about some ideas on an interface for that people can build themselves. So I may be working with someone on building a VLF receiver network, and the VLF receivers would be sold as kits or plans on the internet. And so with that, I'm working on I'm thinking about what I would do for an interface for people to, once they get their VLF receivers, they need to interface it to a computer or Raspberry Pi. So I was thinking about a interface similar to the interface board that I'm doing now for my 3-channel system. Lastly, I spoke to the author, the dev of GPSD, and I was telling him how I didn't have any more pulse width jitter on the pulse per second signal now that the outdoor antenna is installed. And he pointed out that the documentation for both the Res SM360 and the Res 720 mentions use of an outdoor antenna. So obviously, this is what Trimble recommends, but since this is, but this I still feel is an issue, because you could run into this sort of situation in the field. So I am going to contract. I'm going to reopen the ticket with Trimble and see where it goes. That's all I have. Back to the net.
Well, fine business. And next on the list is Steve, WA5FRF. Go ahead, Steve.
Well, good evening, everyone. It's been hot in Texas, over 100 degrees for a long time, going to be 103, 104 later in the week. I let my dogs take me for a walk about an hour ago, and I've just about got them running into the ground. At least they're not tethered, and they can run out in the woods and get off of the hot asphalt if they want to. I've been working at work, but I've got a break right now, so I've been trying to get some more data, and I was going to solicit some ideas from the group on how to digitize some of these spectrograms. Can I show you something on share a screen?
Sure.
That would be this one right here. There, can you see this spectrogram here?
Yes.
Yeah, that's a waterfall. This is 5 megahertz WWV in the morning as the sun comes up. I've been looking at this mode splitting phenomenon for a while. And that's what the abstract was I submitted, was comparing what's happening now. This came from just this very last May. So this is only a couple of months old, 2022. But when I started this, it was back in 2017, 2018. And understudy of this, I mean, we still have the same swings, but a lot of these modes would only manifest partway through the transition. Like they had to wait for the ionization to get good enough to propagate the higher angles. But now they're continuous throughout the whole mode. Here you can see a real low Doppler shift mode, and then here's 1, 2, 3, and boy, look over here. Is that another one? It's about 30 dB down, but I believe it is. If I, what I do to try and digitize these things, first I put it in regular spectrogram format, then optically, like photo enhance it, and you can see, sure enough, that is another mode up there. So I got to digitize this. I've got some analysis routines. I mean, this is Doppler, so it's the derivative response to the derivative of path length change, which means that you can do the inverse integration process on it and come up with a prediction of how the layer height had to move to make these happen. But you got to get this into the computer to do it. So here I reverse the colors, and then the way I've done these is just pencil and paper 101, interpolate as best I can where these, well, the weaker ones, where they actually are. Anybody know of a better way of, I mean, obviously I can't do a lot of this. It's too time consuming. I'll do this one, and I've done one other, but it'd be nice to be able to automate this. Is there a way the grape can do this, or the tangerine, that could actually give you a digital representation of these things versus frequency?
Yeah, are you talking about future data or things that you've collected in the past already?
All of the above. Oh, no, obviously the stuff that's already collected is already collected, and I'm going to take more. No, I'm talking about a way to collect these and get this data. No, not to recover things that are already done. I'm talking about the future.
So the grape will, the new grape, when it's running digital RF, will capture this full spectrum and record all of those details. Regarding getting all of those humps out in individual lines, that's going to require that would require some algorithm development.
Yeah.
Yeah. So to get those lines out that you've drawn there, and to have it all be specified individually, that's definitely going to require some algorithm development. Were you going to
So-
say something, Bill?
I have something to
Yeah, I
say.
mean, we're close to being able to do this now with the Grape One run on the system that I'm running, the running digital RF, so.
I wanted to chime in there. Something I did back in my academic career, I worked on some algorithms that were quantile regression, which allowed you to fit a line to a set of data at a particular quantile. And that might be useful method in this kind of data.
Well, I am very anxious to try some of this with the grape. That really sounds cool.
I
But
absolutely
Meantime,
agree.
this is what I'll be doing for the for now.
Are you able to save the audio files that are going into Spectrum Lab at all?
I can. I haven't.
you-
Yes, I can.
Okay, you should do that, because if you can save those audio files, we can recreate those plots, and then we can do the digitization afterward.
Well, as a matter of fact, I am planning on, you remember back in 17 or 18, I did a simultaneous 3-frequency recording at 2.5, 5, and 10 megahertz on WWV.
Right.
Got that. And so I'm going to do another one of those to compare, now and then, and I'll do that.
Okay, yeah, that would be great. If you just get the audio files and you make sure they're time tagged correctly, we can redo these plots.
Cool. Yeah, all I have to do is run a wave capture program at the same time I run Spectrum Lab. They run off the same input, and I've done that before. It works.
Okay. Yeah, see if there's a way you can get your wave capture program to accurately timestamp the beginning of the file too. Maybe you go off the file creation, like the file creation time that gets stamped, but that's the tricky part with these audio recordings, is getting it properly timestamped.
Yeah, I may have to just, I don't think I'm going to try and record 24 or 48 hours worth of continuous data. Just
Yeah,
the parts in the morning, couple hours worth, 3 hours worth. That's
right.
probably only digitized at 1025 or 1024 instead of.
And probably, I mean, probably if you get it accurate within plus or minus a minute, it's probably good enough for what we need.
Well, the wave capture program starts at time 0 and keeps a very accurate relative time from there. So
Yeah.
if I, for example, push the button at exactly, 1100 Zulu or something like that,
Yeah.
we'll know the start time and just reference from there.
Yeah. Yeah. It's just knowing that, getting that start time correct is the,
I can
trick.
probably get it within a few seconds.
that should be good.
Oh yeah, because this recording that you see up here, these are hour-long increments. This is 1, 2, 3,
Yeah.
4, 5, 6 hours worth of recording right there.
Yeah. That's why I said if you get it within a minute, you're probably good.
Yeah.
I mean, probably even within 5 minutes, you're good.
Well, that's a
But-
great idea. I'll
Yeah.
do that. I'll
Yeah.
record the audio.
Because if you, that's one of the problems we've had with your plots in the past, is we only have the plots, we don't have the actual numbers. But
Right.
if you're actually recording those wave files are actual numbers that we can then, turn into plots and develop algorithms around and stuff like that.
Right.
But those
Actually,
look
that's
beautiful.
better because there the wave file is digitizing just a single waveform, but it contains all the frequencies. Here,
Exactly.
the FFT is already done, and now you got multiple tracks, and they all have components that fall on top of each other. These would be very hard to break out.
Exactly. And that's essentially what Bill is doing with the digital RF grape, is he's essentially saving the wave file.
Right. Okay. I can do that, and I will do that.
That sounds great.
Thank you.
Thank you.
Okay, let's see. Next on the list would be Bill Engelke. AB4EJ. Go ahead.
Thanks. Sorry I'm late. I had the wrong link in my calendar. We started running a beta test on the central control system and learned some things. I have a new uploader program for you, Nathaniel, if you want to start that again. That
Okay.
creates a new observation each day. There's some, I need to add something to it to allow you to select whether you want to upload historical data or just current, the data that, you know, the current day that's in progress. Because it doesn't make sense to refresh all that data every time because the historical files aren't going to change.
Right.
So yeah, so I'll get you something on that. Meanwhile, if anybody else would like to try beta testing with their magnetometer, let me know and we'll get you set up to do that with the central control system. Also just playing around on the NASA stuff with finding a way to perhaps extract the parameters of the underside of the ionosphere from spot data. I believe I'm making progress with some breakthroughs I had just today. So Nathaniel, we're going to have a meeting tomorrow, I suppose.
Yes.
Okay, I'll show you some interesting new plots of that are relevant to that project. So back to Nick.
Great.
Well, fine business. Next on the list is Kong, KC3UAX. Go ahead, Kong.
Hello, everyone. Can you hear me?
Yes, a little overmodulated.
Okay, sounds good. So last week I finished the remote system upgrade part of the Tangerine. So now the users can update the system without having to go through the development environment that I'm using right now, which is
good.
I would guess would be very convoluted for regular users. So after that, I started talking to Tom McDermott to his socket server design. So that was going to be the part of the system that allows us to connect to the internet and allows other clients to connect to the system to exchange data and other essential information. Yeah, I've been looking at the basics of networking because I have very limited knowledge of networking. So I want to integrate what Tom did into what I did to create one coherent system. That's it for me. Back to the net.
Very good. Sounds like you're making progress.
Yeah, lots of good progress last week, actually. Yeah.
Good. Well, speaking of Tom, Tom is next on the list. Tom in 5EG. Go ahead.
Okay, Dave. Good evening, everybody in the group. I spoke with Kong for a while. I'd sent him a couple different versions of the socket server, and I think Kong was able to get one of them to compile. One of them would compile on my machine, but not his. And I think I'll have a little bit of cleanup work there to do to get the latest into an older build version. The build is somewhat complicated. And on another tack, I registered for DCC this morning successfully. The links are broken on the web page. So when you go to DCC registrations open, it gives you an error. But I found the registration page and was able to register successfully. So sounds like it's a pretty simple issue on the web page to get all that straightened out. And that's about it.
So Tom, I reported the error to Stana and she reported back that it's working. So I haven't tested it, but it was just before the meeting started this evening. So
yeah,
so
it was just it just looked like a broken URL, something real simple.
Yep. So I think if people go there, they should be able to register. and just go to the Tapper website. It should be on the page there.
Yeah, log in first.
Log in.
Yeah, if you log in first, your bill will be lower.
Good advice. I'm sorry that it took so long, but there were a whole bunch of complicated issues that went into getting this link up.
Yeah, everything seemed to work fine. The checkout process, the credit card, all that seemed to work just fine. So I think it all got resolved there. Looks good.
I told my students this morning that I was planning on sending all of them to DCC. So I have to handle all those logistics. I was just trying to get through AGU abstracts first. But I guess I should be in touch with Steve
Yes.
Bible with my thoughts.
Yes. I think either he or Stan are collecting the titles.
Okay, I can email both of them.
So
Is Tapper DCC going to have a remote option, or at least a remote presentation option for who can attend?
for a remote presentation, you'd probably use Zoom to record a talk that would be played there. We are not going to run a Zoom during the meeting because of the logistics of the hotel. But we will run a YouTube stream out from the hotel.
Okay.
And of course, we'll record the sessions, so they'll be on the Tapper website later.
Okay, yeah, I won't be attending in a person this year, but I have 2 talks that I would like to submit. So I'll make recordings and submit them.
Yes,
How
what I would recommend.
Okay, how long should they be? 20 minutes?
If you're in that ballpark, you should be fine. I haven't been involved in the program slots, and either Scotty or Steve Bible would be able to tell you that exactly.
Okay, I sent them both an email earlier this week, so
Okay.
I'll just wait till I get back they get back to me.
Yep. So I'll know more later this week. I think we're going to have a Tapper meeting about DCC this week, so we can catch up on those details. Dan, have you heard anything else? Is Dan
I have
there?
not, Dave.
Okay. Since you're privy to the communications, I thought I'd make sure I'm telling the truth.
No, I think you're telling the truth. I did want to mention, though, now that I have the floor, that I'm heading out to Phoenix probably this weekend. And Scotty and I are going to test magnetometers next week.
I thought he's going to help him build his house.
Well, you may try. I don't think it'll be real successful on that one.
Do you have any information on the adapter boards?
I do not, but that's
Okay.
another thing we need to test.
Yeah, because we would
I think
really
they're
like.
built.
Yeah, I know they're built. I just really I'd like to get Kung an adapter board and an adapter board, an RF module, and a clock module as soon as possible, so he can keep
Okay, we'll put a little bit of priority on that.
Yeah, I think, I mean, from my perspective, getting those adapter boards out to Kung and to Tom McDermott are probably the highest priority things.
Okay.
Because once they have those things in hand, they can keep working. But, and I don't know if there's anyone besides Kung and Tom, like, I don't know if Dave should have one, but like, we need to get those to them as soon as possible, because then they can keep busy, and then you can get the magnetometer boards tested. But I think the adapter boards and those and the RF module and clock module are the highest priority, followed closely by the prototype data engines, which I think are either built or being built.
Yeah, I don't know that those are finished yet,
Yeah,
but they're probably getting close. If they're
Yeah.
not done, getting close.
that's it. If we can get those adapter boards out ASAP, it's
Okay.
going to have them like, at the beginning of the summer. But
Yeah.
but yeah, as soon as we can, because we've got to get that tested.
Okay.
Well, and I know you're worried about Kung's time limits coming up.
So I mean, technically his time ends this week. So
Yes.
I have a feeling I'm not going to speak for Kung, but I have a feeling continue doing work on this throughout the school year as part of the faculty student research program. But
yeah,
his
I think he
official,
finds it interesting, so that helps.
it does.
Yeah, I would love to do that, but another problem is that during the school year, I may have other classes and other projects come up, so I would have less time to dedicate to this project.
Mhm.
So that's why I really want to play around with those hardware,
Yeah.
way before school starts.
So like if we can get something out within, even if it's like overnight mail, I will pay for the overnight mail. I can get that reimbursed.
Okay.
But we need hardware desperately.
All right.
So I think we're done with the roll call and open for general discussion.
Would actually, would it help if Kung went to Arizona to help test these boards? I'm not even joking.
I don't know. Talk to Scotty about it and see what he says.
All right, Kung, we'll give Scotty a call tomorrow.
Okay.
I've got a question about DCC and reading the website. First, it talks about Zoom, not YouTube. I guess it does have YouTube there, but it does talk about Zoom. Is that actually, what's the Zoom function in
Part
there?
of it is bits and pieces left from the last couple years. Where
Okay.
we did everything on Zoom.
So that may be inaccurate.
The problem with doing Zoom from a hotel is they can't guarantee us the bandwidth we want.
Right. Yeah, I'm aware of that. So
And
I just wanted to
and-
point out that there's a little discrepancy there.
We felt that it was better to use most of the bandwidth for the streaming than to take up bandwidth with Zoom going in and out.
For sure. That should work fine. The other question has to do with the price. Is it the same price remote as in person?
I haven't actually logged on to the site yet, so
There's, I don't see
think
a difference, so
yeah,
that's why I'm wondering, because I would be a remote.
yeah.
All right,
Okay.
thought I'd bring that up.
You can always register for your annual dues.
No,
I
I
got
got
a
that
question.
already. That's not a problem.
Dave, I got a question.
Yes.
My math skills may not be all that great, but I see an entry for all activities at $310.
Yes.
And when I add everything up, it comes up to $305.
Well, I wasn't the person that did that, so I don't know.
What, I just want to know, is there, a
Send-
free soda for all activities or something?
Dan, do you have a answer for that?
I do not, Dave. I didn't do this side myself, so I don't know.
It's not real difficult math. I could have screwed it up, but
No, I think you might be right. I'll take a
Okay.
look at it. We'll get that sorted out.
We'll-
the $5 isn't gonna break me. I'm not, it just like, is there something missing off that list that I don't see?
Yeah. I know that we were talking about one price for early sign up and then another one for at the door. Is that
No, it's not. No, that's not
Okay.
listed. It's just
And
the
then
first
there's
entry on the
one
list
for,
is
members. There's a price for members.
I'm in on a member account. So
Okay.
and maybe one of the entries is wrong. I don't know.
Yeah, I'll look into it, James.
It's either, yeah, we'll make sure that it gets taken care of.
Maybe it's an
Any of
IQ.
you-
Is it an IQ test? You figure out which way it's
Yes.
cheaper.
Yes.
Yeah. Yeah.
Does the all activities price include the food as well?
I'm assuming it does, because that's what everything adds up to.
Yes.
Yes.
Okay.
Well, it's kind of like the stuff in the supermarket where the mid size is actually cheaper than the large size.
That's right. It's like Walmart.
Maybe it's a processing fee to keep track of everything.
No, there's probably a good explanation for it, but I'm not sure what it is.
I'm not worried about it.
Whoever did up the discounts probably rounded off.
That could be, because those are discounted prices.
Was there something I just signed up, and was there something I was supposed to click to differentiate between in person and online?
No,
I don't see anything. I
no.
didn't. Okay, that's fine. Well, it worked
It's
fine. for
just
me.
that David and Jonathan both said they are not attending, but they're interested in following it.
I
Well,
got it.
if you're just going on YouTube, isn't that free?
Yeah, that's free.
Right. So if you just watch YouTube, there's no registration cost at all.
Ah, well, that answers that question.
That would seem a rational explanation. I do see that the Sunday only is listed at $5. I don't know what that might be, the $5 difference.
Could be.
I didn't sign up for Sunday, so.
Yeah, I saw that. Look, it was confusing at first. That's the discount that's being listed.
I see.
Yeah, that's probably the closest. The Sunday discounted price is $5 less than the full price. That might account for it.
I know this probably goes without saying, but for presenters that are submitting recordings, it's best to just list your email address or whatever for questions. Or will there be?
Probably yes at this point. Yeah.
Okay.
In case anybody missed it earlier, I do want to say that there is a refreshed version 1.1, not yet fully tested, but available, of the Run Mag program for the magnetometer that hopefully incorporates Bill Engelke's changes and hopefully works suitably.
And I will attest, I'm running it on my site at this point. And so far it seems to be working, but I haven't tested the numbers, so. That would be the KV0S data without a number. And I think I've got just 1 day of data with the new system. I didn't check the timing on it, but I did check the numbers from the old system to the new system, and they appeared to be the same.
Well, if you do just a line count, what is it, LC on that
Yes.
log file, you ought to see about 8,600, whatever it is. But I can't think there's command LC, isn't there?
I think you should be probably getting 86,400.
Well, that's what I
per
mean.
day.
Yeah, that's a little better. That would be better. Yeah, sorry about that.
I'll do
Mine's
that.
still offline and I couldn't shake it down properly. I thought that was a little low.
Nathaniel, what did you need that VLF presentation for? Is that for AGU?
He seems to stepped away. I don't know if he's there or not.
So I remember last week, this is where he went and read a book to his kid.
Yeah.
Speaking of that, I need to sign out. 7-3 guys, enjoyed it. Thanks for the tips. I appreciate it.
Okay. And look forward to seeing more of your data.
Thank you. Talk to y'all later. Good night.
Bye.
I haven't got anything more, so maybe I'll head off into the sunset as well.
Yeah, I was gonna, sorry, I had to go step away for a minute. Dave, oh, we should probably talk about that Hardware X paper that we started talking about at Hamvention.
Okay.
How would you like to go about doing that?
What are your thoughts? I have when I realized it wasn't urgent, I kind of focused on doing a simpler paper just to talk about, communications with sensors. So
Yeah.
for now, okay.
So I think the time has come to actually do it and try to get a draft done or get submitted by the end of the year.
Oh, okay.
Does that sound?
You were saying next year. Okay. All right.
Yeah.
All right. Okay.
Does that sound reasonable?
It's entirely reasonable. I assumed I was going to work with Jules and Marty on it. Yeah. I may have to refresh my thinking about it, but that's fine.
Okay. And I can work with you on like outlining it and kind of figuring that out. But basically the goal would be to write a paper that documents the whole process. That documents the magnetometer.
Uh-huh.
So we have one paper already like it that documents the grape version one. So do I do another paper that documents the magnetometer in a similar way?
Okay.
Okay.
Yes. And you gave me a copy of that paper, and
I can send it to you again.
It wouldn't hurt. It never hurts.
So I can actually send it to you. Let me get that up. hamsci.org. And ULF papers, Hamvention. There's the paper right there. I'll put the link in the chat, but I can also email it to you, and I can email I can email Jules and Hyomin as well. I guess. Why is this not letting me? Oh, because I have to accept all cookies, of course. Copy link address. There's the. All right, new. Okay. To. All right, yeah, I'll go ahead and send that to you, Dave. So thank you.
Nathaniel, what did you need those VLF slides for?
What did I need the VLF slides for?
Yeah, remember the ones that you wanted me to prepare?
Oh, we were gonna try to write, like, actually do a science, figure out some sort of a science presentation, right?
So I kind of share Bill's sentiments that it's not very easy to kind of correlate VLF activity with HF activity,
Right.
except for Doppler shift.
Right.
Now, I was thinking about an experiment, a similar experiment with the grape, but instead of WWV, it's a VLF transmitter, and it uses a GPS locked frequency reference.
Mm-hmm.
So to the group, if I could generate a GPS locked frequency reference for a VLF transmitter, let's say NAA, am I going to see Doppler shift like is seen in WWV?
What you mean on the NAA carrier?
Yeah.
Yes. But it'll be very small.
Right.
But when it goes from day to night, you're definitely going to have a phase shift, which will look like Doppler.
Okay.
So, yeah.
Thinking of trying an experiment.
I think that's a really good idea. How much smaller would that Doppler shift be, David?
That's a good question, because of course all you're changing is the waveguide. You're not like moving the ionosphere like you are bouncing off the F layer.
Mm-hmm.
Right.
Yeah, we don't really even think of it as frequency shift at that point. You're actually tracking the phase.
I guess the question I was posing to Jonathan the other day was, okay, we have this personal space weather station that has a ground magnetometer. He has an HF receiver, which, we have the grape that's working right now. And then we also have this VLF receiver. Are there any sorts of studies we can do that would take advantage of all, either, more than one of those things? Like, can we have the grape and the HF instrument look at us, do some sort of coordinated science experiment?
That's a good question. Now, one thing I'll point out that if you go back and look at any of the old literature on WWVB, when it was being used as a frequency reference, that it would have very similar propagation to something like NAA. And then any shifts that you see there, of course, phase shift is a frequency shift. So you could look, I'm not remembering how much of a shift there is, but it's very measurable. In fact, you had to keep track of it. And NAA at 24 kilohertz would be approximately a third, or one, divide by 2.5, the shift of WWVB.
Well,
just from the frequency difference.
VLFRX Tools plots the absolute phase of measured signals from NAA and others. And what I notice is phase shifts throughout the diurnal. I could show you an example, and I was thinking about those phase shifts as something that we could put in the paper.
Now, of course, one thing I'll point out is to get phase off of NAA, you have to decode the minimum shift keying.
Yeah, that's what it's doing.
Okay.
Because I have some plots here that I sent to Joe for his event that he was showing off solar flare data. Where's that shot? Here it is. So here is an example. This is absolute phase. Here, let me share it. So this is an example of the phase shift that I see with a SID. So it's about 100, and so it starts around 60 at the beginning of the UTC day, and it goes back and forth between 60 and 160 throughout the diurnal. And I thought that was really interesting. And I figured that was due to the changing of the waveguide throughout the day, just like you mentioned.
Well, that should only change at sunrise and sunset. This is much more active than that.
Yeah.
Yeah, why would there be so many changes? It seems rather regular at the beginning of the day, and then in the middle of the day, it becomes very irregular.
Yeah, that's suspicious, those big phase jumps.
Because so when the carrier is much stronger, that's when you see those regular phase jumps. But once the carrier goes weaker and they bring down the carrier power, that's when you see. So some of that could be noise too, but only NAA produces this sort of plot. NLK has phase jumps. It seems like 180 degrees, and they occur like every half hour. Now it has to do with with the modulation, of course, but I thought this was an interesting effect here.
Yeah, was this while you were having trouble with your GPS reference?
No, actually, when there's no GPS reference, the bottom plot is all noise. This is when it was working properly.
Yeah, that doesn't, I'm sorry, that doesn't make sense to me that it has these
What do
phase
other
jumps, and the fact that the phase jumps are the same going across.
what do other days look like?
Other days actually look pretty similar.
The amplitude, I believe, because, well, these are UT, right? Yeah. There, you did have an actual null in amplitude, which does happen.
Yeah, they seem to bring down NAA like at around 10 or 12 UT.
I don't think that's bringing it down. I think that's the day-night shift. And you actually have a phase cancellation.
I could bring up today's plot. And I could also bring up other transmitters too. But yeah, I thought that was. So here is 7:29. 24 hours. Okay. So this is yesterday, 7:29. This is kind of what I get. This is NAA, and remember, this is absolute. So according to the documentation, it's measuring absolute phase against the GPS reference.
So where does the MSK demodulation come in?
Let's see. That would be in the documentation here.
Yeah, the thing about that's complicated with NAA is it's not actually at 24 kilohertz. It's either 50 hertz high or 50 hertz low.
Right.
I'm wondering if this is just losing sync with the picking up one frequency and then another frequency.
Well, so according to the documentation, what it's plotting here is absolute phase. Let's see. If the input stream is timestamped with sufficient accuracy, for example, using GPS pulse per second, the absolute phase can be logged mod 360 for CW signals, and mod 180 for MSK signals. That's what the documentation says.
Uh-huh. Yeah, so that's why that's displaying 180 degrees. That makes sense.
Yeah. And
I missed that because my Starlink froze for me. Can you say that again?
He
Me
said
or-
that, yeah, for a continuous wave signal, it plots 0 to 360 degrees. And for a MSK signal, which NAA is, it plots 0 to 180 degrees.
Okay.
So I
for-
think that what's happening is it's not the thing about doubling the frequency. That's different.
So this right here, this is NLK, and this is the phase plot that I typically get.
Wow, that's like not even on frequency.
Now, this also could be noise as well.
Well, what's suspicious is that you've got this constant phase drift.
Right, because if you unwrap it, it's just like it's continuously dropping in phase, right?
Right. So that's a continuous phase shift like that is a frequency offset.
Right. And so NAU, this is NAU.
NLK is which one?
The one in Washington.
Washington, okay.
So this is NAU. And the phase plot here isn't really usable. Here, I'll share this. Yeah, this isn't really.
Yeah,
So
that's interesting. So that's really off frequency.
yeah, NAU.
That's interesting. It's plotting 360 degrees too. Because I think
Well,
NAU's got to be the same MSK.
the way that it's configured is it's treating NAU as a CW signal because it was recommended that it can't really be used for measuring phase, absolute phase. But yeah, this is NAU. Now I would like to plot some other transmitters as well. But I have to. I'll need some extra processing power for that. But yeah, this is. Those are typically the plots, and I've been trying to understand those changes in phase for a while, and I don't really understand it. So I'm going to post a question on the VLF group board and see if Paul answers.
Yeah, it looks like something's not locking.
Yeah, because with the NAA,
Yeah, that's just what I get. And then when there's a SID, there's often a change. If it's strong enough, it'll actually show that phase flip too.
Right. But on a quiet day, it should be fairly constant phase during the day. Then you see a shift. It may be a few wavelengths shift, and then constant during the night.
Do you think that that could be the waveguide?
Well, that's what I'm saying. In a quiet day, the waveguide's not changing, except at the day-night shift.
Yeah.
So
Have
the
you
phase
looked?
should be quite constant.
Yeah. Have you looked at the geomagnetic activity along with any of these?
No, I haven't. But I didn't because of how much that changes throughout the day. It didn't seem to correspond to any sort of geomagnetic activity. But that's what I wanted. I wanted to pose this question to Paul, since he's the one that wrote this software, if he thinks that this is normal. Because I haven't been able to actually look at other people's phase plots. I always see their amplitude plots, but not their phase plots using this. But I thought that was really interesting. But I think NLK is much too weak, so it's not going to produce a consistent, you know, a similar phase plot. Because NAA is actually really strong where we are.
Can I share screen? I guess that any of us can. Let me just set this up here. This is what the phase plot should look like. This is WWVB as received in the Eastern United States, back before they started playing with the encoding stuff in the phase. So as you see, it should be very constant phase during the day, and then it'll shift at sunset, stay constant overnight, and then it'll shift back during the day. And NAA should look even more stable than that if it's being properly decoded. This comes from the NAST time and frequency manual.
Okay. Well, yeah, I'll try to get some more information on that, because I've been seeing those my phase plots since I put this in, and every time that I had GPS running, you know, that's always what I would see. So I wanted to pipe the stream into a higher power computer and capture some more signals. NMK,
as well. I think that's at 25 point something. And I want
24.8.
no.
Use the 40 kilohertz one.
No, the one in Nebraska.
Oh, Nebraska. Okay, sorry.
I think that's NMK, around 25. Which on
well, there's a North Dakota. Is that what you mean?
or
NML
yeah. Mhm.
25.2.
Yep, NML. Yeah.
Okay.
Because on the spectrum plot, I can actually sometimes I can see that.
Yeah, you should. If you can see Seattle, you'll certainly see North Dakota.
I could bring that up actually. We can see the live spectrum. Oftentimes I get Europe's VLF transmitters too. Increase the resolution here. Oh, there we go. Okay, and I'll share this. So we have, right here we have NAA. This is NLK. This is NAU. And then we have this little peak over here at 38 kilohertz. I believe that's a transmitter over in Europe.
It's either that or it's your monitor.
Yeah.
There's 37.6 in Iceland. You might be seeing.
I think that's what that is. Yeah. Yeah. So that's what could be seen right now. But obviously that changes throughout the day. But so what I monitor are usually the strongest ones, and that's why that I monitor those 3. And this is the raw signal without the mains filter.
You might actually be seeing Hawaii in there too. They're at 21.4, and I see a little peak over there.
Yep. Yeah, I could see that too. Yeah, see, a lot of those are actually, just below the noise.
Yeah, your signal to noise isn't fantastic there.
Yeah.
I'll have to go to my loop tonight, see what I'm seeing.
Yeah. But that is pretty cool.
Yeah, we were able to pick up NAA off of a short E-field probe on our rocket with good signal to noise. Yeah, it was 2 spheres separated by 30 centimeters, and we got a good strong signal.
Was that rocket local to where you are?
It was from Wallops.
Oh, okay.
That was the Viper experiment we did a year ago.
Oh, right, yeah. Um, yeah, seems like NAA, that's the strongest signal that I get. So for WWV, I would have to use a higher sample rate, because I was wondering what the signal levels were on that, but the fellow in Forest, Virginia, on his website, he um, makes plots of um, different transmitters, and he plots NAA and WWVB and others as well. But
Right. Yeah, I can't remember what the power of WWVB is. It's a lot more than it used to be. But
yeah,
of course, all our radio controlled clocks are picking it up, so it's pretty easy to get it up above the noise.
yeah, mine usually set in the middle of the night.
Yeah, that's what they do because the signal strength is better.
Yeah.
But we have the with the phase modulation that they've put on it now, it ruined it for us time nuts. But it, if you have the right receiver chip, it picks it up very well. I was able to receive it reliably from Greenland when you used to not be able to get it here in New England.
Right, right. Yeah, there was a receiver project that someone did in a amateur radio magazine. It's actually a couple boards. The antenna is a ribbon cable that's wired into an actual, you know, multiple loops. And he put it in his attic. That was on my list of things to build. It's still on my list, but I haven't really played around with the phase modulation yet with the WWVB. But yeah, that's interesting. Why? Well. So I believe that the noise floor, especially from um, 4 kilohertz to 20 kilohertz is so high, is due to summer lightning.
It's due to what?
Summer lightning.
Oh, yeah.
Because in March, when I was playing around with this, that the noise floor was much
Yeah, well,
lower.
that's the band of the Whistlers.
Yeah. Yeah, and actually, because I mean, if you listen to the stream, there's just the lightning has been fairly intense, so that's why that it's a little bit noisy. So it's also harder to decode amateur signals. But yeah, that's definitely summer lightning. In the wintertime, that'll be much lower.
Well, very good. I think I'm going to go QRT.
Sounds good.
Yeah, thanks for the
Thanks.
updates and everything, Jonathan. David, I'm gonna go try to fix a bug in some plotting code.
Good luck.
Thank you.
Don't stay up too late.
I won't. I'll probably go to bed by like midnight or something like that. Maybe sooner. We'll see how much determination I have. Thanks, Jonathan. I'll talk to you later.
All right, thanks, guys.
Somebody
Sounds
Bye,
great.
David. 7-3.